Okay, in this video, we're going to learn how to write chemical formulae for ionic compounds. First, we're going to learn how to write chemical formulae for binary ionic compounds. These would be compounds that are made up of a metal and a non-metal only. Okay, before we do that, we need to learn a little bit about valency. The valency of an element, it's like basically its combining power. It's the number of electrons that it needs to lose or gain in order to have only full shells. Okay, you're all familiar with the periodic table. Well, we can use the periodic table to work out the valency of many of the elements. Group 1, the group starting with hydrogen, they've all got a valency of +1. Group 2, +2. Group 3, +3. Group 4, plus or minus 4. Group 5, -3. Group 6, -2. Group 7, -1. And the noble gases, they've got a valency of 0. There are a few exceptions to that rule. For example, lead, even though it's in group 4, it's actually got a valency of -2. Now, you'll notice there's this whole middle group there that I haven't written a valency for. A lot of those, so they're called the transition metals, a lot of those, their valency is +2. But again, there are a few exceptions to this rule. Now, at year 9 level, you don't need to learn all of those. The main ones that you will need to learn are the ones that I'm highlighting now. So silver has got a valency of +1, copper +2, zinc +2, and iron can have a valency of +2 or +3, but in most instances it's +3. So at year 9 level, we'll just learn it as +3. Okay, now let's go through the rules for writing chemical formulae. Rule number 1 is that we need to write the symbol for the metal first, then the non-metal, and we cross the valencies. So let's have a look at aluminium oxide. Aluminium oxide is made up of aluminium and oxygen. So let's go back to our periodic table. Okay, that's aluminium over here. It's got a valency of +3, and that's oxygen over here. It's got a valency of -2. So aluminium +3, oxygen -2. When I write the formula, all I need to do is cross those numbers. So the 2 goes with aluminium and the 3 goes with oxygen. So the formula is Al2O3. Stop the video and have a go doing aluminium sulfide on your own. Okay, the answer is Al2S3. Hopefully you got that right. Okay, rule number 2 is that if one of the numbers is 1, it doesn't get written down. Okay, let's see how that works. So the first example we've got there is magnesium chloride. Okay, magnesium's over here, valency +2, and chlorine's over here, valency -1. So magnesium, valency +2, and chlorine, valency -1. So when we write down this formula, the 2 from magnesium comes over here. The 1 from chlorine should go with magnesium, but because it's a 1, we don't actually write it down. So the formula is just MgCl2. Okay, you have a go at doing the next few examples. Pause the video whilst you do that. Okay, you can see the formulae on the screen. Hopefully you got those right. Rule number 3 is that sometimes you will be able to simplify a formula. So the formulae for ionic compounds are like ratios, basically. So if you can divide all the numbers by the same thing, you can cancel down. Okay, let's see how that works with magnesium oxide. Back to our periodic table again. Okay, magnesium is over here. It's got a valency of 2. And oxygen is over here. It's got a valency of 2. So magnesium, valency 2. Oxygen, valency 2. So when we write down the formula, the 2 from oxygen comes over here and the 2 from magnesium comes over here. So the formula should be Mg2O2. But because both of these numbers are 2 and they can both be divided by 2, we can simplify down. So that formula actually becomes MgO. Okay, try the next few examples on your own. Pause the video whilst you do that. Okay, now things get a little bit more complicated. We've got to learn about the polyatomic ions. Now, what polyatomic ions are, they're a group of atoms that combine together and act as though they are one thing. So the whole polyatomic ion has a particular name and it's got a particular valency. So in year 9, these are the polyatomic ions that you need to learn. Okay, so you need to actually learn these. Okay, you can't look them up on the periodic table. You will actually have to know them. All right, now, when we have a polyatomic ion in a formula, the whole thing gets treated as one thing. And if we need to put a number with the polyatomic ion, we'll need to use brackets. So let's have a look at how that actually works. Okay, the first example that we've got here is aluminium sulfate. Okay, aluminium, we can look that up on the periodic table. The symbol is Al, and the valency is +3. Sulfate is a polyatomic ion, and you can see in the table, the formula is SO4, and the valency is -2. So what we're going to do is that the number 2 from sulfate is going to go with aluminium, and then the number 3 is going to go with sulfate. But because we need a number to go with a polyatomic ion, we're going to have to use brackets. And you can see how I've done that here. So the formula is Al2 bracket SO4 bracket 3. All right. Now, all the rules that we learned before also apply to polyatomic ions. So, for example, if there's a 1 in the formula, we don't write it down. Okay, so the next example that I've got here is sodium hydroxide. Sodium on the periodic table is Na with a valency of +1. Hydroxide is OH with a valency of -1. So when we write down this formula, the 1 from hydroxide goes with sodium because it's 1, we don't write anything down. And the 1 from sodium goes with hydroxide, again, because it's a 1, we don't write anything down. So the formula is just NaOH. Okay, let's have another example, this time with sodium carbonate. Okay, so sodium, Na with a valency of +1. Carbonate is a polyatomic ion and its valency is -2. So when we write down this formula, the 2 from carbonate will go with sodium and the 1 from sodium will go with carbonate because it's a 1. Again, we don't write anything down, so it's just Na2CO3. Okay, and the other rule that also applies is about cancelling down. So with copper sulfate, for example, copper, we can look that up in the periodic table. That's Cu and it's got a valency of +2. Sulfate is a polyatomic ion. It's got a valency of -2. So when we write down this formula, the 2 should go with copper and this 2 over here should go with sulfate, but because they're both 2's, they can be cancelled down. So the formula just ends up being CuSO4 and we don't write either of those 2's. Okay, see if you can have a go at the last 3 examples on your own. Pause the video whilst you do those. Okay, so what you now need to do is to get lots more practice at these types of questions. So I've sent you a link to some examples of questions. Make sure you practice those so you get really good at these.